Every single time you click a link, like a video or hit send on an email, you're kicking off an incredible invisible journey. Today, we're going to follow one of those messages, step by step, to see how the internet actually works its magic in the blink of an eye.
I mean, it really does feel like magic, right? You click something and a web page from halfway around the world just appears. But it's not magic at all. It's a super organized, incredibly fast process. And to really get it, we need to rewind to a time when the internet was, well, kind of broken.
So picture this. In the early days of networking, computers were like these separate little digital islands. A computer from one company could talk to its buddies, sure, but it had no way of communicating with a computer from a different company. This created a huge barrier, keeping the digital world all chopped up and disconnected.
So how did we fix this? Well, a brilliant solution came along called the OSI reference model. The easiest way to think of it is as a universal language for computers. It's basically a set of rules that every single device agrees to follow. This way, a message sent from any machine can be understood by any other machine anywhere on Earth. It's the rulebook that connects all the islands. Okay, so this model is broken down into 7 distinct layers. And here's the key. When you send data, your message travels down through these layers. At each step, it gets wrapped up and prepared for its big journey. Then, when the data arrives at its destination, it travels back up those same layers to get unwrapped. Let's follow a piece of data on its trip.
All right, let's get into the nitty-gritty. Let's say you're sending a photo to a friend. That photo is your raw data. But before it can go zooming across the internet, it needs to be carefully packaged up, kind of like preparing a fragile item for international shipping.
It all starts right at the top of our 7-layer model. This is your actual message. The text in your email, the photo you're uploading, or the website address you just typed in. It's the what of your communication. Simple enough, right?
Okay, so the first wrapper gets added at what's called the transport layer. Here, your data gets broken down into smaller, more manageable pieces called segments. This layer then slaps a header on each piece, kind of like numbering each box in a big shipment. Why? To make sure they all arrive safely and can be put back together in the right order. This whole step is all about reliability.
Now we're getting somewhere. The next step at the network layer is to add a proper mailing address. This is your IP address. This layer adds a header with the source and destination IP addresses, turning our little segment into what we now call a packet. Think of this as the global address that lets your data travel between completely different networks.
And for the final piece of packaging, the data link layer adds one last tag. If the IP address is the street address for the entire building, think of this header as the specific person's name on the mailbox for the very next stop on the journey. This complete package, now called a frame, is finally ready to be turned into a signal and sent out onto the wire. All right, our data is all packed up and officially on the road. But how does it actually navigate the massive, complex digital highways out there? Well, it relies on 2 crucial traffic cops, switches and routers. And each one is designed to solve a very specific kind of traffic problem.
So, first up, we've got a problem called a collision domain. Just imagine a single-lane road where only one car can drive at a time. If 2 devices on a network try to speak at the exact same moment, their signals crash into each other, a collision, and they both have to back up and try again. Old-school network gear created these huge collision domains, which meant constant traffic jams.
The other big problem is something called a broadcast domain. The best way to think about this is a town square. When someone makes an announcement, everyone in the square has to stop what they're doing and listen. Now that's fine once in a while, but if there are too many announcements, it just creates a ton of noise and slows everything down because every device is constantly being interrupted.
And this is exactly where our traffic cops shine. A switch and a router each solve one of these specific problems. A switch is your local guy. It works inside one network, breaking up those big collision domains. It's like a smart mail sorter in an office building, giving each device its own private lane so there are no more crashes. A router, on the other hand, is the long-distance operator. It connects different networks together, like an airport hub directing flights between cities. It uses the big picture IP address and, crucially, it stops all that noisy broadcast traffic from spilling over from one network to another.
So, after zipping across the internet, our little packet finally arrives at its destination. And now, that whole packing process we just talked about, it happens in reverse. It's time to unwrap the present.
First things first, the receiving computer's data link layer looks at that outer wrapper. It checks the hardware address and sees, yep, this is for me. It then strips off that outer layer and passes the packet that was hiding inside up the chain.
Next up, The network layer takes a look. It checks the IP address on the packet to confirm it has, in fact, arrived at the right destination network. Once it confirms that, it unwraps its own header and passes the data segment up again.
And here's the final and most satisfying step. The transport layer gets all those little numbered boxes, the segments. It uses that header information to make sure none of them got lost along the way, puts them all back together in the correct order, and voila! Your original photo is reassembled and handed off to the application, ready to be viewed. The journey is officially complete.
And that right there is the whole point of this system. It's why this whole journey is so incredibly powerful. Every single device, every layer, every router, no matter who made it, follows these exact same rules. This universal agreement is what finally broke down those old digital islands and allows our modern interconnected world to exist.
I mean, just stop and think about that for a second. This entire ridiculously complex journey we just walked through happens millions of times every single second. It's an amazing feat of engineering, but it also means a lot of things have to go perfectly. So the next time your internet is a little slow or a page just won't load, you'll have a better idea of what might be happening. It's just one tiny step in this incredible high-speed dance that's hit a little snag. It kind of makes you appreciate it all the more when it all just works.